Hello to everyone. This is Serverless Reality, and I'm Lynn Langit. Some of you might be familiar with my work. I've been a technical speaker for many years. I'm a former Microsoft employee, and I've been an independent cloud architect for about 7 years now. I do most of my work in the United States. I live in California. I also speak and travel internationally and create courses on cloud and big data topics. For this work, I've been recognized by Microsoft with the MVP Award, Google with the Google Cloud Developer Expert Award, and Amazon for the Community Hero Award. Because I'm independent, this gives me a unique perspective that I'm going to share with you today. I'm going to be very frank and honest, and if there are people from Microsoft, Google, or Amazon in the audience, I don't mean to insult you. My primary audience is the working developer. I am one of you. I have deployed serverless solutions. I have had pain. I've also had happiness, and I want to share both. So in this talk, I will talk about what my definition of serverless is, because it's very important to start with the common basis. I'll show you examples of serverless from the different vendors in case you're new to one or more vendors. I'll talk about patterns architecturally, because I do work as a cloud architect that I'm seeing both presently and on the near-term future. And probably most importantly, and hoping you'll have the time and inclination to stay to the end, in the end, I will have very frank talk about the lessons that I have learned working in this space. So to get us started, I'm going to take a use case from the country of Australia. In Australia, there was a large effort to put the national census online. Now, whether or not this is serverless comes into play later in the story. The point is, it was a very large countrywide enterprise project, and the government of Australia proudly launched the Australian census on a Friday evening, and this is what the Australian citizens were greeted with. So the question becomes, clearly didn't work, how much did the government spend on this project? What was the architecture, and what does this have to do with serverless? The government spent over $9 million working with a vendor, it was IBM in this case, over a more than a year-long period, and had a complete and utter failure. 2 students at a hackathon a month later in Australia, after having attended an Amazon community event, built a complete functional copy of the website in 3 days using a serverless pattern at the cost of $500 and load tested it so that it could bear the load that was experienced on that Friday. And this is a really dramatic case. Not every workload is the right fit for serverless, but for those that are, there can be incredible economies of time and money. And that's why I think all of you are here today. So let's start with some definitions. What is serverless? There's a whole bunch of terms out there. Is it functions as a service? Is it serverless without servers? Is it microservices? Is it Amazon Lambda? Is it functions as a service? Is it using actual VMs, nano VMs, for example, from Amazon? What is it? Well, you're in my talk, so you get my definition. My definition of the world of serverless started in November 2014 when Amazon launched Lambda. Now, I'm not so familiar with the Norwegian cloud market. I don't do professional work here. But in the US, Amazon is utterly dominant currently in the cloud. They have 16 times the business of all competitors combined. And at reInvent in November of 2014, when they launched Lambda, they again changed the game. There was immediate and intense interest in the economies of time and money that Lambda made available. And in fact, in the professional work that I'm doing in the US, I would estimate that 50% of the projects that I work on now have some sort of a serverless component, most usually on Amazon, but increasingly with some of the other cloud vendors, as I'll talk about when I get into this a bit more. So in case you've not seen Lambda before, in case you're entirely new to it, I'm going to show you what it looks like. Now, because we're at a large conference, and I'm talking about the cloud, but we can never be dependent on the speed of the cloud, what I've done is I've recorded this. Now, I recorded this in Norway. So I did this in Bergen. I've been in your beautiful country for a bit of time now. I did some traveling in the North Fjords. It's beautiful. Anyway, so I took a break when I was in Bergen. This is the Amazon console. And you just bring up the Lambda service and click the blue button like you do anywhere in Amazon to get a sample. And when you're first starting, I suggest taking a look at the blueprints. There are blueprints for Node and Python, although C# is now supported significantly. You can just click on a blueprint. You could associate your Lambda with a service in Amazon. This is one of the strengths of the Amazon offering. But for this simple first example, I'll just run some code. And now you give your function a name. And I just happened to select Node because it was simple, but again, as I said, you could use C# or Python or your favorite language, basically. And you can see on line 5, we have an event that we're going to fire. And now we need to give it a security permission. And we're going to go ahead and create the function. And in the interface, you then can see the function, and you can test the function. You can configure an event that's appropriate to the function capability. In this case, we're just passing some values in. And once we click test, the function will execute and we'll see the results. And we'll see that we had a successful execution, and we see summary of the log. Now, one of the things that's different, of course, in the serverless world is your build on executions and resource consumption, which does differ by vendors. In the case of Amazon, you set the amount of memory, 128 megs being the basic amount. And there is, of course, monitoring via CloudWatch. Here's your logs, and I invoked it a few times there just to show what it looks like. And a significant aspect of working with functions is allocating the appropriate resources. And there are my invocations and my duration, and I didn't have any errors. And that's really all there is to a basic function. It's just executing code. So when I was driving around beautiful Norway with a colleague of mine who happens to do more work in the Azure world, his name is Anton Delsink, he and I came up with this definition of the serverless environment. Rather than saying serverless, we like to say that Lambdas are containerless. So not only are the servers abstracted away from the developers, but also the containers. So as an architect, I always have to scribble on a napkin. So here's my napkin drawing. There are quite a few talks in this conference about microservices. And if you're coming new into this era of microservices and serverless, it might be a bit confusing. And one of the challenges that I see when I'm designing architectures is when to take a microservice approach and move it into serverless, because they're two different things. And this is the way that I like to think about it on these two axes. On the left side, I have management and control, so more up here, so that you have more control of your physical server, but less management. Moving down to a virtual machine, moving down to containers and Docker, moving down to Lambda. But of course, in terms of service costs, the service costs are dramatically less. People often ask me, C-level people, how much difference can it be? And although there's always going to be it depends, as a rough guideline, it's very typical that a Lambda implementation will be 1/100th the cost of running servers. Now, there's an interesting sort of additional pivot to this, And I just overlaid this here. And this is the thing that I mentioned earlier, but I'll continue to mention because this does come up as an alternative in the serverless environment. Sometimes when you're in microservice architecture, serverless is not the best approach. You want to have microservices, but you want to have servers. And in the Amazon environment, I've done quite a bit of work with nano VMs as well, which are $5 US a month. So you get the economies in cost, but you still have a server. So that's kind of one of the first things to think about, microservices versus serverless. Another aspect of serverless is most people just think of serverless as compute. And that's really too narrow. Serverless in some ways was launched not in 2014, it was launched in 2006 when Amazon launched serverless file storage with S3. If you're not aware, S3 is the most widely used cloud service on the planet by far. And it's interesting to note that not only Lambda and S3 are indicative of the serverless services that are being offered, but really, in a broader scale, all of the cloud vendors, and I just happen to be most familiar with Amazon, are creating the entirety of their offerings going forward in a serverless basis. So what does that mean? You have file storage, you have compute, but then serverless offerings that I've done quite a lot of work with over the past 12 months have been serverless services around Internet of Things, so IoT brokers, machine learning, flowing data, kinesis. So this is a sort of general pattern in cloud services. More and more of the offerings are offered in a serverless manner, not just compute. So here's my definition. Serverless to me is public cloud services for compute, for data or files, and other processing, such as machine learning. They are functions that abstract away both containers and servers. Actually, as an aside, this will be a bit controversial. I'm personally not very much interested in Docker. I'm not very much interested in Docker. I'm not interested in container orchestration. I am getting the best economies of scale for my customers by either selecting servers and or serverless. I find Docker and containers to be a bit of a kind of a distraction, a bit of noise. And I know I'll probably have people that really disagree with me, but that's just been my personal experience. So, serverless defined continued. Serverless is built on executions, not server instance sizes. And services that are based on events and easily and nearly infinitely scalable. So that's my definition of serverless. From a high level, the general types of use cases and patterns that I find serverless to be the best fit for are three. The first one is a huge volume of activities, so running web requests, queue messages, transactions. Also, to isolate and scale tasks. Another common use case is dynamic workloads, like the Australian census that I showed you. Run something infrequently, once a day, a month, a minute, whatever, and avoid paying for servers to get those economies of scale. Alternatively, I've also used serverless for scheduled tasks or jobs. Again, trying to get the scale economy by using a service that's only built on execution, not for an entire server. So run a certain piece of code on a schedule. So in the Amazon ecosystem, this is the core, the basis pattern that you see over and over and over. And this pattern is really emerging to me as a similar pattern in both Azure and in the Google Cloud. So there's three types of serverless services in this pattern. The first type is around the bottom here. These are the data services. So you have generally some sort of S3 buckets, and then you have some sort of data repositories. It's most often shown as DynamoDB, which is a NoSQL database. Then you have a layer of compute, which is n number of Lambda functions. And then if you need additional capability, and the most common scenario is you're going to expose this outside of the Amazon cloud, then you're going to use a different kind of serverless service like the API gateway. So this is a pattern that's a core that you build on over and over and over. And of course, in, for example, Azure, it would be Azure Blobs, and it would be now, I think it's Cosmos DB, it used to be Document DB, as well as Azure Functions, and then the interface pieces that would sit in front of it, and similar in Google. Speaking of vendors, I'm going to show you a bit of demo just so you can see what the function interfaces look like with two different scenarios. Just really simple event-driven, listen on a bucket or a file bucket, if you will, or a timer for Lambda, Google, and Azure. So here's a bucket, and I'm going to create a function using a template against S3. And there, the trigger is pre-populated. I just need to set it to the correct region. By the way, I did a speed test when I was in Norway, and I found the EU London region to be the fastest. And I can talk to you separately on how I do speed tests, but it's kind of something I do for fun when I travel. So this is setting us to this bucket. I'm setting the event type, and I'm enabling the trigger. So when an object file is placed into the bucket, then the Lambda code will run. Again, very simple code. And you can see if I scroll down here that on line 10, I have an event handler for the context. And then on line 20, I'm calling S3 instance with getObject passing the parameters. Now, in this case, my IAM has to have permission to read that bucket, using the best practice of the permission only for executing the function and the bucket, not using, admin, which you should not do, obviously. Now, anything I'm showing in the console, of course, you could use a command line tool and or use an SDK and do this programmatically, and that's what you do in production. But it's just faster to show the console. Demo's a little bit better than a wall of command line. So here I'm uploading a picture of beautiful Norway. Extra credit if you know where that is. And then once this upload completes, the Lambda will fire. And of course, you have to make the bucket in the same region as the Lambda for this to work. So if you're testing it out, I recommend you guys use London. And there's the trigger. And it takes, because of the warm-up time, it takes more time than you'd expect initially. And there's the log. And you look in the log, and you can see that you've got a JPEG. Now, there's a reason I'm emphasizing the logs. When we get to the how do you programmatically work with this, you can't, of course, SSH into a VM or a Docker container or anything like that. So you will be using the logs quite a lot when you are developing. You don't have to access them in the console. You can do it programmatically. So here's Google. As of today, Google Functions are in beta. So although they're powerful, I wouldn't recommend using them in production until they go to GA. So I'm creating a bucket here. Google's interesting in terms of its buckets. It has 4 different options: multi-regional, regional, nearline, and cold line, which correspond to Amazon, but it's a unified API. So I really like working with their file system. Also in the Google implementation, you create a folder in a different bucket, and that's where your zipped JavaScript code for your function goes. When you work in the console in Amazon, you don't actually see that. And I do like that in Google, that you see where your code is. Another concept in Google, there I'm turning on the API. Google has this concept of reducing the attack surface, and also has a concept of a container for your cloud services. You'll see on the top says Oslo demo up here. That's a project container, which is a really kind of a nice feature. So I've turned on the API, and now I'm creating a function in the console. Again, because it's beta, it's only available in US. I'm sure it'll be Europe. The memory allocated goes higher for Google. They have 3 scenarios: Cloud Pub Sub, Cloud Storage, and HTTP Trigger. It's a webhook. So there's your cloud storage bucket. So the UI is nice and familiar, very simple to compare. Their sample code's a little cleaner. You can see on line 7, they have a process file, which is collecting the event data. And here I'm making a bucket, because this is required in the Google implementation to store the JavaScript code. So even if you want to test to listen on a bucket, you have to have 2 buckets, different than Amazon. And once you do that, then make a folder, and then it's executing the process file function, and then we're creating the function. Similar UI in terms of the trigger, the source, and the testing. Can configure test events similarly to Amazon. And then inside of here, you just upload a file, and then the event will trigger. So the familiarity is useful, actually, because considering, at least in my world, most people started with Amazon. There's another picture of beautiful Norway. And you have the upload, and then the event will fire, which will run the code. So there's the staging code, which is zipped. So that's another implementation detail. With functions, you zip the JavaScript or whatever the code you're using. There I'm switching back to functions. And in the UI, I'll see that I have 1 execution. You can see over to the right here, that's the execution. Then I'm going over to the logs. The logging story is super important, as I said, because that's a key tool for you. And Google's done a really good job. They purchased this company called Stackdriver, and they have very extensive logs, even though the product is beta, which I think is great and really useful. So now, once this is done, those are the resources. We'll go over to Azure. So Azure has an interesting interface that's separate from the main console that I discovered and I really liked. So you can do an Azure function in the main console, but again, just to try things out, this is really kind of nice. So you go to this URL, and I'll post this so you guys can see it after. And you can try out functions with no credit card or anything. It's kind of cool. So I just recorded this off of this console rather than the main one because it was quicker. So you can see you've got C# has a first-class language here with examples. JavaScript, there's many more languages supported, but these are the most common scenarios. You auth in with GitHub or something. And then this is sort of your test harness user interface. You get an hour where you can just try things out. It's really nice for just testing if you're going across systems. Now, something significantly different in the Azure world, as you see on the right, they have a function.json, which I'll show you in a minute. So this is just running it. So this use case is just running a piece of code. I didn't bother to listen on a bucket here. It's just a timer, basically. Assuming that most of this audience knows C#, not explaining the code very much. So what's interesting about the implementation here is this function file with bindings. So Amazon does a really good job integrating with Amazon services. I really have to give it to Azure in that they do a really good job integrating with Azure services, but they do, I think, the best job integrating with external services as well. And so this is done through bindings. There's a key, and then there's a monitoring functionality. So that's like a really, really quick preview through the 3 different interfaces, just in case you've never seen functions before. So the state of serverless compute, right now, like I said, in my world, Amazon is utterly dominant. I'm doing all my work on Amazon in production. I am really interested, though, in what Microsoft has done. I was at Serverless Conf in Austin, Texas a month ago and really got to kind of see what's going on with Azure Functions. And then, like I said, my colleague that I did the road trip with, he works more in the Azure world, and I'm really pretty impressed with the offering. And I will be doing more bake-offs between the two because of the breadth of what Microsoft's offering. That being said, though, Amazon's not sleeping. They have introduced what they call Lambda at the edge for IoT. It's called Greengrass. That actually came out last week. So if you are working with IoT, sensors, that kind of world, I really encourage you to take a look at their new Greengrass implementation. It allows Lambda to be executed at the edge at a CDN or on devices. It's really interesting functionality. In the Azure world, something that I think is really interesting is something called Logic Apps, which is a higher level abstraction that allows a less code. It's a GUI designer to do integrations. I encourage you to take a look at it. I think there's talks on it here. Really excited about it. Another thing that is interesting in the Azure world is there's 2 billing plans. One is basically identical to Amazon, which is called consumption, billed on how many times it executes. There's another plan that acknowledges that customers will have this sort of mixed world where they'll have some servers, let's say web servers, and they'll want to co-locate functions, and that's called an app service plan. So again, I haven't done as much production work in the Azure world, but when I was talking with my colleague, he was talking about the use cases, and I could really see how that would be interesting to a lot of people. So that's something to be aware of in the Azure world. In the Google world, I'm really hoping that Google can bring their functions to GA as soon as possible because I think they're very performant. I'm very excited about them, but I'm just not going to use beta technologies in production. Google is interesting, though, not only for functions, just pure compute functions. They have a whole bunch of other services that are delivered serverless, and some of them have been around for a while. So I did a whole talk at Serverless Conf that you can see online called Serverless SQL. And this service, which is called Google BigQuery, is something that I have been enamored of for many years, and it's been around for many years. It basically is the ability to upload CSV files, there's some other types, but text type files, and to do full ANSI SQL queries against them at a very, very cheap price. So I'm going to do something really crazy because I just like BigQuery so much, so we'll see if this will work. I'm going to try to run this query live. So this is a really complicated genomics query. I've been doing some work in bioinformatics, so DNA sequencing and stuff like that. And one of the things that's great about BigQuery is they have a lot of reference data up already loaded for you. So in genomics, when you're doing matching, you match against the 1,000 genomes reference database. So that's already up there. So you can really run some queries very cheaply because they don't charge you for the data that they're already hosting. So this query is really complex, has some really complex SQL inside of it. So you can take all the SQL you know and love, and for those of you who know me, I have actually written 3 books on SQL Server. I'm a very big fan of ANSI SQL as a language for processing. And so, you can leverage the things you know, right? So if I go ahead and I run this query, and I hope I'm connected to the internet. Yeah, it's running. Okay, good. So this query will process over 4 terabytes of data. And when I ran it in Bergen, it took 30 seconds. So we'll see how long it takes here. And it costs $5 a terabyte for the scan. So in the US, I have a lot of use cases where people just want to, I call it party on the data, whether it's bioinformatics or whether it's social media, that kind of stuff. And I have a lot of customers that no matter which vendor they're working with, they're using BigQuery. And that's pretty good, hey, right? I'm in Norway. This is running on a US data center on a conference Wi-Fi. And I processed nearly 5 terabytes of data in 36 seconds. And I aggregated 84 million rows down to 2,500 rows. I mean, this service is very impressive. And it's serverless. Serverless SQL. It's been around for many years. Just serverless, it was kind of serverless before serverless's time. So it's interesting in that, so that's the results there, that it's so impressive, it's something that Amazon is paid attention to. At their annual conference, reInvent, in November last year, they introduced a service that is similar but not identical. So SQL on text files, if you will. It's called Aurora. So very interesting to look at some of these new services that are coming out that are serverless, providing us with functionality, SQL, in a serverless fashion. And I'm finding lots of use for this, in addition to compute and some things we talked about. So, talking about the basic services. In the world of Amazon, it's really interesting to see that the core compute services can be nearly free. There are 1 million requests a month that are free for Lambda, and if you use the small Lambda, the 128 megs, which isn't always going to work, but if you do, it's basically free forever. If you add up it says X number of seconds free. So if you take that into seconds, into minutes, into hours, into days, it's basically free. Now, if you use bigger Lambdas, more resource consumption, they're not going to be free, okay? And it's not always going to work this way. But there are some relatively well-known use cases. There's a company called A Cloud Guru that runs a set of training videos, and they actually designed a serverless architecture, and they kind of joke that they've never gotten beyond the free tier, and they have 10, 20,000 customers a month. So it's interesting. Now, on the other side, just to be complete, I've also done blended architectures that have nano instances, as I mentioned earlier, and then I'm starting to do architectures that also have spot pricing, for bursty workloads. So you really have this sort of different options around compute. The high-level situation is that compute and file storage are becoming commodities for Azure, Amazon, and Google. That's good for all of us, kind of. These companies are not, they're in business to make money, so why are they doing this? Lock-in. This is the thing for us to really consider. This is the cost that I can talk about that none of the vendors are going to talk about. This is where the battle lines are being drawn. If Amazon or Microsoft or Google can get you to use their serverless services, starting with core compute and files, and you put especially your data up in their cloud, the chances that you're going to move it go lower and lower with more data that you put. So this can sometimes be a case for using a certain language or using a certain architecture. And I'll give you an example from the real world. I was lead architect on an enterprise IoT project 2 years ago or so. And Mission Critical, the company makes industrial devices. And I think that there's a lot of use cases like that here in Norway. And so they chose as a language Node, even though they were a .NET shop, because they did not want to be locked into a certain vendor. And they felt that if they used Node, they could then move around to different cloud vendors, depending on what was most advantageous. They also chose to use nano instances in some cases rather than Lambda for that same reason, because those were like VMs that they could move around. All right, let's talk about patterns. So this is the core pattern, and I kind of introduced this earlier, but now this is an actual implementation. This is the sort of the canonical reference architecture in Amazon. So for those of us like me who come out of the relational database world, this looks kind of familiar. Dare I say it? It almost looks sort of like stored procedures, right? Sort of, kind of. But I mean, mapping what you know to the new architecture, I think, can be helpful for those of you that have that background. So you can see from a design pattern, we have here create, read, update, and delete. So access to a database. We're abstracting it away through these lambdas. And most importantly, we have one lambda per function, one per verb. Very, very important. One of the most common things I see done incorrectly in serverless architectures is lambdas that are too bulky. Lambdas that are too bulky is an anti-pattern. So you can see here you have static storage in S3. You have lambdas for access. You have API gateway. You have DynamoDB. In this case, you're just connecting out to services as well as Alexa. You see this pattern over and over and over. So is this the pattern that Netflix used? Netflix is always at every Amazon conference. They are the one that changed it all. They are the one that went serverless. They are the one. I don't know if you guys know this, but Amazon actually sometimes will run 1/3 of the US internet traffic. The entire US internet traffic. Yes, we're watching too much TV, but that's a different discussion. So are they the one that kind of put serverless over the top? Nay, they are ikke. It's beer. It's beer. Kind of kidding, but kind of not kidding. So simple beer service is an implementation of the reference architecture that I just showed you with one twist. In the front, rather than a website, it literally is a kegerator. So here is the GitHub repo, and I have a homework for all of you who want to actually build something serverless, make the world a better place. You can go here and you can get the information starting with the hardware. So you can set up the kegerator and connect it to the Amazon cloud or Azure if you want to. It doesn't really matter, but I just happen to have the Amazon one here. And you can then add, this is a goal for me. I would like to see an Oslo entry here before I leave on Friday, and I will hack with you. So if you want to build this with me, I'll be here all week. This is the dashboard that shows from the kegerators in the Seattle office, the San Francisco office, and in Sydney, what the beer flow is coming off the kegerator. And in addition to being sort of fun, it actually is a reference architecture that implements serverless. Like I said, the difference is it's using the IoT services rather than straight Lambdas. But it's an interesting use case. And again, I'm thinking you guys in Norway have a lot of IoT interest because of the sensors and oil and gas and all that kind of stuff. So fun to build. So that's the architecture. So if you want to look at other architectures, those guys from A Cloud Guru, one of the guys, Peter Sparsky, published this book. And although it's serverless architectures on Amazon, I think it's also good across Azure and Google. It's patterns. So he has some of the patterns that he's made public, and I just want to highlight a couple of them here because I really recommend this book. I mean, highly. So you should get it if you're going to be building on this in this situation. So he starts with Lambdas themselves, and this is a really common pattern, and not just in Lambda, but implemented in Lambda. That you have a Lambda out in the front that's a command Lambda. So one of the situations that you run into with Lambda is because it is running in a Docker container. It's just you don't control the container. Is you might need to have a Lambda that's an invoker that sits and listens to see if the other Lambdas are actually alive or not, and if not, wakes them up. So again, this is sort of practical reality. Now you can do it in front, like this. Hits the API gateway, or comes in from the API gateway. The invoker sits there and says, are these Lambdas awake? No, wake it up. So a Lambda that wakes up a Lambda, and then sends some information to a database. Or you can do it the other way. You have data coming in, going into some sort of queue, and then you need to send this data downstream, and you need these Lambdas to be awake to minimize latency. So this is one of many patterns that I've implemented, but just wanted to share, just to give you an idea in terms of the chaining of Lambdas. Now, taking it a little bit more broadly and going beyond compute Lambdas, I build big data pipelines. That's what I do professionally. So Snapchat clones, Instagram clones, YouTube remonetizers, bioinformatics stuff, so big data, lots of IoT, big data. So what are some of the overall patterns that I work with that are serverless or mostly serverless? So this is an IoT. This is Amazon IoT. This is similar to the pattern that I built for the enterprise group. So Amazon has a very strong story around integration with MQTT protocols for IoT. And these IoT rules are basically specialty Lambdas that when data comes in from the device, you set the thresholds, and it's all GUI-based, so it's very simple to implement. And then notice the core of this architecture is the serverless. You send the data that has been processed through to Dynamo, and then you do subsequent processing on Lambda, and then you serve it up to the dashboard on the API gateway. So hopefully there's some familiarity here. And notice, no servers whatsoever. None. 0. Reference architecture. But again, going back to that slide about lock-in, vendors are going to show you these architectures. It's in their own best interest. The real world sometimes can be more blended. For example, in this scenario, we had a special security requirement, and we used small EC2 instances as our custom security servers because we wanted to have complete control over that. So you see this pattern a lot. This is a data stream coming in through Kinesis pipe. And then you have a cold path over here, the red, going into the bucket, and a hot path going to the Lambda, going back to Dynamo. And then you have some processing going in. They call it a Kinesis app. So at the Serverless conference, there was an architecture competition for serverless architectures. And the US retailer Nordstrom won with basically a more sophisticated implementation of this. And this is what it looks like. It looks kind of intimidating, but it's really just that separation of concerns. So, you take a picture of some product, and then you send it in with some lambdas to the API gateway, and then you partition based on functions. I call it based on verbs, if you will. And then you store, cold path, some information here, or some reference data out of your bucket. You do your processing, and then send your information through to Dynamo for state, because, of course, lambdas are stateless. And then, do subsequent downstream processing with Lambda. So this is the sort of high-level serverless architecture that can be used for certain use cases. Just to be complete, Google has a set of services. Like I said, it's interesting. Of their services, I think the actual core functions, obviously, because they're beta, are least mature. But they have many other sophisticated services, like this is a similar one with the hot and cold path, like PubSub, which is like Kinesis, which is very mature. So I have built these streaming big data architectures very, very successfully with Google using some of their really powerful services like BigQuery. And this is just a more complex version. Again, you've got it's probably too much to consume in great detail, but you've got the streaming path and you've got the batch path. And then they're serving up with services like BigQuery and Data Lab, which is Jupyter Notebooks. Another use case that I'm doing quite a lot of work in, and I would just share with you, I don't know the Norwegian market because I don't work here other than speaking here, but in the US, there is a huge skills gap between developers who can code and machine learning and what my customers need. I am actually literally going to universities, and I'm hiring university students while they're still in school because they've had machine learning courses. Machine learning is coming fast, really, really fast. All 3 vendors have very compelling offerings. And where I'm working on it is this use case up here, which is bioinformatics. I actually have a different talk in this conference on Friday about some work that I've done. But the idea is the scale of data requires predictive analytics or machine learning, because you can't just use simple aggregation anymore. But anyway, so in the world of the vendors, they have machine learning as a service. They have specialized APIs, like an Amazon Polylex and recognition, Google Vision Speech and Video API. And then they are working on these open source projects that have started out of academia for the really computationally intense problems, the deep neural nets. And Amazon has put their hat in the ring with MXNet, and Google has TensorFlow. Very interesting because these computationally intense workloads take advantage of GPUs. And Amazon and Google have GPUs as a service. I'm just not as familiar in the Azure space. There's lots of Azure people here, so I'm assuming they have similar offerings, because everybody is really, really trying to get offerings out there. So I talk about this from two reasons. 1, customers want it. 2, educate yourself. And I guess I'll just take my little 1-minute sidetrack here. I don't care how old or how young you are. If you're interested in learning this stuff, it is highly, highly possible. I have been working on learning advanced calculus. I think there is a talk here on implementing the Lambda calculus that I'll be sitting in the amount of learning that is necessary in our industry to be able to service our customer need is significant. And those of us who embrace lifelong learning are going to be very successful in this area. And those that don't, aren't. So, speaking of that, lessons. Okay, so let's talk about some real-world problems. I've implemented Lambda in production with several customers. So these are known problems, but again, you came to my talk to get reality, so maybe you haven't experienced this yet. Warm-up time is a known problem because of if you need always-on Lambdas, there's the initial warm-up time because of the Docker container. Understanding how to properly store state is not really a problem, it's just an architectural challenge. And then there's mystery and freeze and thaw errors, the scary things. So for warm-up time, I showed you the pattern, warming trigger. You can do CloudWatch events. You can set it, I just put 5 minutes. You can put whatever time you want, basically. For state, I've shown you the pattern over and over to store the state externally, either in S3, which of course you should encrypt for anything that has a high security need, or DynamoDB. This is a little bit more subtle. For mystery errors, allocate more Lambda memory. Remember how I said you get what you pay for? The 128 meg Lambdas are pretty much free, but you get what you pay for. So sometimes you have to bump the memory up. And if you're working with Node, this is just, my projects have been in Node, use the latest Node.js versions on the Amazon cloud because that's what they're optimizing for. And use shorter operations. Common sense, but very, very important in the world of serverless. So Lambdas are more than coding. So you're going to look at, is Lambda available in your programming language? The previous guy who was talking about C# and the C# community. I was really happy to see Amazon announce support in Lambda for C#. I love C#. Haven't done any work in C#, unfortunately. Haven't had any demand. And I'm really hoping that, like he was making a call to the C# community to be more open and be more inclusive. I love C#. It's a beautiful language. I feel sad, and I'll tell you that in California, I'm having very little demand for C#. It's all Python and Node. So you have concerns around debugging, unit testing, integration testing, orchestration, and deployment. So debugging patterns. Azure comes out really strong here. Microsoft's always had a great tooling story. They have a local emulator. The Visual Studio tools are great. Fantastic. If you're a .NET developer, very compelling. The story on the Amazon and GCP side is not as happy. What I did for testing and debugging, I used Mocha, Chai, and Mox, so it was a lot of pain. Basically, these are libraries for Node. You want to code via testable patterns, supports and adapters, so it's on you to code properly. And there are starting to be utility libraries such as Lambda Tester, and there's an alpha version on GitHub for GCP. So it's a painful kind of story. In the world of security, what I see whenever there's a paradigm shift in technology is developers don't like caring about security and they tend to let it drop. And this is nothing new. It's just one slide for, follow best security practices. Credentials that are unique, small attack surface, test your external connections, minimal permissions, granular policies. Nothing new, but just don't ignore these things. This is a picture of Azure Logic apps. Again, I encourage you, if you're working in the Azure environment, to take a look at this. When I was traveling around with my friend Anton, he said he was frustrated because whenever he was thinking of writing an Azure function, he went and looked at a Logic app, and the integration was already written for him. So, kudos to Microsoft for that they have so many of the common integrations. So this is an orchestration UI that generates JSON code. And it really showcases the ability to orchestrate functions very powerfully. On the Amazon side, they have step functions. Of course, you can use CloudWatch alarms as triggers, but step functions, which is in beta. And this is more of a focus on flow rather than integration. But I do have one customer I'm working with, so if you're interested in getting some real-world information about this, I will be blogging and writing about the implementation of step functions in it's a bioinformatics workflow. And Amazon's starting to publish reference architectures here. So again, they're pushing all things serverless, and they're publishing these architectures around orchestration, which I'll be leveraging when I'm working with my clients. And I wanted to make you aware they're already doing this. In terms of deployment, again, Azure has a great story, kind of same thing. They have nice integration with Visual Studio. They have ARM or Azure Resource Manager JSON templates, and you can use PowerShell to deploy. Always a strength with Microsoft. On the Amazon side, still got some work to do, although CloudFormation, which uses YAML files similarly to the ARMs, now has extended to support functions by SAM templates. There are a bunch of third-party templates that I've seen more often over previous time. Terraform is commercial, serverless framework, Claudia.js. So the SAM templates work in the CloudFormation Designer, and I actually have a little demo of how this works, if you've never seen this. Oops, let me get out of here. Whoop. Go out of here. There we go. There, OK. So if you're not familiar, I'm just going through the environment saying I have nothing there, nothing there, nothing there. So I'm going to deploy that reference architecture. So I'm going to do this with a CloudFormation stack. And I'm going to do it through the command line. So I have a YAML file. And you can see on line 6 there, this is the SAM extension. So type AWS : serverless : function. So this is configuration as code, which is an extremely important practice in cloud, even more so in serverless because you've got more objects to deal with. And this is going to deploy all of those Lambdas, those buckets, and the DynamoDB and the API gateway. And then this is they put all the Lambda code kind of sloppily in one index.js just to make it quicker. It should correspond to each Lambda, of course. And this is, as you can see, like on line 33, events.put. This is putting into, on 44, Dynamo put item. So this is using the Lambda to connect to the DynamoDB. So I'm running this from the AWS CLI. The first thing that I'm doing is I'm running on line 1, when I put this into my terminal, AWS CloudFormation, and I'm taking that YAML file, and I'm specifying where to put it. Because it has to, in order for CloudFormation to execute, it has to run from a bucket. So I'm just saying, put that YAML file in this bucket, which it does. And now it makes a new YAML file that says where it is, basically, because one of the things CloudFormation does for you is it versions the stacks or the YAML files. So it's like a GitHub in a way, or source control, I guess, if you will. So now I'm going to deploy this, and I have the capabilities flag because I have to create an IAM or a permission for this. And this will deploy that entire architecture. So it will deploy. Definitely recorded this because it doesn't go as fast as in the video. Okay, and this is from an Amazon sample, so I can put the link in the presentation if you guys want to try it. And I did this from here, so it works just fine. You have to put it in US East, though, unfortunately. And there's all the creates of all the Lambdas. So everything's done. It takes about 5 minutes. And then you get a nice log, so you can version all this stuff. So if you've never seen cloud solutions versioned, that alone is worth the price of admission to this talk. It's extremely important. Production, don't click on the console. Only for demos. So there's my SAM template. There's my Lambdas. So I have a get, put, and delete. Familiar pattern, hopefully by now. It's associated to the API gateway. And there's my DynamoDB. And I can put an item. And if you're not familiar with API gateway, this puts a REST endpoint on your Lambda. And you can see that you have basically REST interface here. and you can put authorizers and all the things. It's API management. So, and there I'm just putting some items. What I'm going to do in the interest of time here is I'm just going to move up to, there's the designer. So that's what the CloudFormation designer looks like. It's a visual designer. And then you can diff your change set. It's a JSON file. And then you can also cleanly remove. Great. This is great for testing, too. I mean, obviously, it's great for production. This is how you build your deployment pipeline. And this pattern is actually, like I said, extreme. So now I'm going to delete this, and I'll remove all the resources. This is extremely important for serverless because you have more objects to deal with. You're not, having 3 EC2 servers or something. And then once you delete the stack, all the objects will be gone. All right. So monitoring. So Charity is a very famous speaker. She's a DevOps person, lots of experience. And she's basically expressing the rage of the DevOps people, which I don't have any other way to state it. It's very challenging for people whose careers were made on monitoring servers to be handed serverless architectures. So the reality is they're afraid and angry. Now, how we had success with one of the big projects I worked on is we used a technique called mob programming, and we integrated the DevOps people. They also went for Amazon training. So Woody Zula's here. He's the father of mob programming. And I worked with the mob for more than a year. Or you can talk to Woody, but it is a very powerful technique when you have this amount of change, because the DevOps people are really, really feeling unsettled by serverless architectures, and justifiably. All right, so let's get real. Serverless. Costs are so cheap. Coding is so easy. Configuration is a breeze. Transparent error reporting. Serverless is great for developers. Monitoring is easy for DevOps. Deployment is simple. Serverless is best for everything. Boy, I sound like I still work at one of those big vendors, don't I? Nope. Costs are cheap, yes. Coding can be easy. You have to think in a services, microservices kind of a style and implement that way. Configuration can be manageable depending on how you are comfortable with the tools, whether it's CloudFormation or whatever tools you use. Do not click on the console. Do not click on the console. Do not click on the console. Really bad. Transparent error reporting, maybe. You might have mystery errors. Sometimes you can solve them by just bumping up the resources. Sometimes you just have to learn how to read the CloudWatch logs. Serverless is great for developers. Maybe. Developers mostly love it initially, but then when they realize they can't SSH into a container, they don't love it as much. I actually had a team who told me it was impossible to implement an architecture that I drew. So unfortunately, we fired the team and built the architecture. Monitoring is easy. No. There are new tools. They're powerful. Amazon, for example, now supports monitoring of Lambda with X-Ray. Google has Stackdriver. But they're new. And DevOps people do not like change. That's why they're DevOps people. They maintain systems. So do not underestimate the need for education, integration, and training for DevOps people in serverless solutions. Deployment is simple. Nope, you need tools. We wrote scripts at one client because they just refused to use CloudFormation. It was hell. Don't do that. Use tools. Buy Terraform or whatever it is. Use tools. Serverless is best for everything? No, absolutely not. It's best for the types of workloads that I talked about initially. Variable workloads, workloads that have isolated portions, workloads that are spiky, not for everything. So what's the reality? You can always use servers, and you might want to. So I recommend when you're making your architecture, whatever cloud you're working on, you actually evaluate using server-based architectures, and you take into consideration aspects such as control, such as learning curve, such as estimated cost, the full picture. And you'll most often end up with a blended solution. Pure serverless is for things like simple beer, not necessarily for the things we work on yet. The market status, of course, Amazon's a market leader, building new features. Azure, I see copying Amazon, but also adding, the tooling is great, and then adding these integrations. I'm really very, kudos to Microsoft. I'm going to be showing customers Azure as well, who are interested in that ecosystem. Google, please get your functions out of beta. I really like your serverless services. I'd like to see your functions. And that is serverless reality. Thank you.